So today we have Dr. Paul van Staden and Dr. Renee Stender, who will be giving the lectures for today. And I have the pleasure to introduce them. And just briefly, as I had already started, that Dr. Paul van Staden has a PhD in mathematical sciences from University of Pretoria, where he is currently also a lecturer in the Department of Statistics, where his research focuses on statistical distribution theory, in particular, the construction of generalized families of probability distributions in the quantile statistical universe. And also he has an interest in sports analytics, where his research interests include team and player performance measures in cricket, modeling of score distributions in rugby and cricket, and rating and ranking systems. And he has done a lot of collaborative work in various research projects. And today we will have the honor of him giving us a lecture, hopefully on the amazing work that he does. And also we have Renee Stender, and I was looking around on the internet for some bio for Renee, and I would say that the one that I stumbled upon under the under SASA, the South African Statistical Association, lists Renee as a young statistician. So we have also the honor of having her today giving a lecture, and she's also a lecturer in the Department of Statistics at University of Pretoria, and also holds a PhD in mathematical statistics. And her research, she has done a lot of research, and she thought she would end up in the financial industry, but now she is a lecturer in the Department of Statistics, and she shares her passion of teaching. And I would say you, the participants of the CSS, are also lucky to have her share this passion for teaching with you. And without wasting any more time, I would hand over to you, Renee and Paul. And to the participants, I hope you enjoy and engage with those two amazing lecturers. Thank you.
Thank you so much for the introduction. I just want to make sure that you guys can see my screen.
Yes, we can see your screen.
Okay.
It's just not full screen for now.
Yes. I can't remember how to make it full screen.
This is Adobe.
Yeah.
Control L.
Ha, thank you. Okay. So welcome to today's session. So as the introduction said, me and Paul will take you through probability and statistics for this coding summer school. So I think it's more of a brief introduction to get you interested in statistics. So obviously there's a lot more that we can tell you, but we are going to give you a brief introduction. Okay, so just the outline for the 2 days that we have with you. So for today, I'm going to take you through some data handling and data manipulation in Python. So that is just how Python works with data and some things that you can do in Python so that your data is ready. Okay, so working with data. And then the first part of all statistical analysis is your exploratory data analysis, where you start looking at your data, what your data contains, how your data looks, and we will also do that today. So how exploratory data analysis in Python works. And then tomorrow, Paul will tell you more about some analysis on categorical data and numerical data. Okay, so the two different data types. Yes, so there's some resources. So the first is, it's 2 books, freely online, freely available online. So the first is Computational and Inferential Thinking. So this first book focuses more on a Python aspect. And then the second one is An Introduction to Modern Statistics, which is, the book is mostly focused on R programming, but the way they explain the statistical concepts is very good. Yeah, so Paul, is there something that you want to add to this introduction?
No, I just want to say hi to everybody and hope you enjoy. Today is the nice day. I don't know if tomorrow will be so nice when it's my turn to do most of the speaking. I've seen what is coming today and looked for me excellent. So yeah, I hope everybody enjoys what's coming. Thanks.
Okay. So throughout the day, if you have any questions on what I'm presenting, please share it in the chat on Slack, and we will look at it as we go. And maybe, Paul, if there's something urgent or that you feel that you should interrupt me, please do.
We'll do so, but yeah, everything's fine.
Okay, perfect. Thank you. Okay, so let us jump right in. So first of all, what is statistics? Okay, so statistics is making sense of numbers. We are making informed decisions in the presence of uncertainty and variation. We're never certain if we're making like predictions. It's always, there's always some uncertainty and variation. Yeah. So, and also in statistics, we organize and summarize data so that we can draw conclusions based on the information that we get from the data. So one of the concepts that I just want to explain to you is a population versus a sample. So to collect information on a whole population is very expensive, it's very tedious, and it can in most cases not be done. So what we usually do is we draw a sample from this population that is representative, okay, which is also not going to go into sampling techniques today, but if you just get the concept that we take a sample from the population, we take data from the sample, and we are trying to make inference about the population. Okay. So the population is the collection of objects about which information we are looking for, and the sample is what we observe. So that's the data that we have. Right. So then what is the data? So the data are the raw facts that we collect, analyze, and summarize so that we can make these informed decisions. In data, we are usually interested in certain characteristics or objects, depends on the situation and what we are interested in. And in data, we observe variables. That is any characteristic whose value may change from one object to another, okay, such as eye color, height, color of a car, temperature from day to day, marital status. That's everything that we can observe from individuals. So there's 2 types of data. It's categorical and numerical. So categorical is where you have categories such as eye color, Okay, marital status, there's certain categories. And then numerical data is more quantitative. So something that you can count or something that you can measure. Temperature is a numerical variable. It's something that you measure. Height is also a numerical variable. Okay. The number of cars, it's something that you count. It's a numerical variable. Yeah. And we analyze these data differently. So data is everywhere. Everywhere you go, there's data. Data is collected in this technological world that we live in today. Data is collected everywhere. When you make a purchase online, data is collected. When you click on an advertisement, when you interact on social media, it's data that's collected. And when you stream music or movies, the data is collected to make suggestions for you for movies and music to listen to. When you use something like Airbnb and review an experience, when you engage in physical activity on Garmin, you know, all these smartwatches, the fitness smartwatches that we wear, it collects data. And all in the background, there's statistics behind everything to make suggestions or, yes. So what does a data set look like? Okay, so this is just an example. So it consists of rows and columns. In the columns, we have something that we call variables. So the variables are stored in the columns, and each row consists of one element. So it's usually, sometimes it's individuals. So each row will then be an individual. In this case, it's province data. So each row represents a province. And then we have data for each variable for each province. Okay. And each cell represents an observation. So it's a variable that's observed from this specific individual or element. Okay. And that is what we're going to work with today. So it's important that you know how a data set is structured. So the first part that we're going to do today is data handling. So I just drafted here some things that we can do in that we're going to look at. There's obviously more. This is just to get you started, get you excited. So we are going to import data sets into Python. We're going to see how we extract variables, how we can remove variables, how we can subset data on different ways, removing observations, creating new variables, and removing duplicates, because duplicates sometimes just an error when typing in your data. And we're going to sort the data. So these are just some data handling things that we're going to work with. And then for this exercise, we are going to use data from an online game. So this website is actually, I added the link here. It's very, it's actually quite cute. There's a few online statistical games that you can go and play, and you can download the data afterwards. And so we're going to use the data from this game to do the data handling. So it's on a racing game. Okay. So on Slack, on Canvas, I added a Python script called data handling, and you can download that and open that in Spider or whichever Python interpreter you're using, and we are going to work through that together now. So I'm going to jump over to Python as well. Okay, I'm just going to give 1 or 2 minutes for everyone to open up this Python script. I think it will be beneficial if you want to note something down, if you do it in the script and save it on your own device, then you have everything together. So I'm going to just give a minute or so for everyone to open this up. So I see someone is asking in the chat, where's the Python script? So it's on Canvas. So I uploaded it to Canvas. It's the one that says data handling.
Okay, sorry, Renee. I just was also I wanted to say, regarding Zoom links, as they indicate there in the chat, you need to ask your champions for Zoom links. Renee, I don't have Zoom links that we can share. We could access a link that was given to us, but we cannot share any links for Zoom. You must ask your champions at your institution. And then, as Renee was saying, thanks, Benjamin is showing there on the chat now where to access.
We do have some time, so I will wait a minute or two more.
Yes.
I think it's better if we
The
start.
question from my side, Renee, because you've done it, because I'm on multiple devices currently, so they can follow everywhere. I installed the Canvas, but on my iPad, but I cannot access anything regarding the NITheCS or the some school. I guess I installed the wrong Canvas version, so I will maybe uninstall and try again. But yeah, don't know which version did you install, Renee? Because you're also on the app.
Okay. I'm on the Slack app, just the Slack app.
Oh, not on the Canvas one. Okay, then okay,
Yeah,
then
the
I will
Canvas,
see. Yeah. Okay.
Canvas, I'm using I'm just using it in the browser.
Yeah. I will do the same, Benjamin. Benjamin also told me I must just be on the browser. I will do that then. Yeah. No, I thought it would be easier if I do Canvas also via an app, but it doesn't want to easily work. So no problem. I will go back to browser for Canvas. But yeah, for Slack.
Just before we start, I just want to confirm that everyone can see my spider and the script that I'm sharing.
Yes or no? I can see.
I see.
Assuming then all the others can also.
Right. So for the data handling part, when we're working with data, we work with pandas, with the pandas library. So that's all package that we're going to need for the working of the data. So we import pandas, and the default is to import it as PD. So this PD, I'm sure most of you know this, is like an alias that you give to the package so that you can work with a shorter name when you are extracting functions from the package. Okay. And the next package that we have here is just OS, and this package we're just going to use to set a working directory. Okay, so for me, everyone has their own way of working sometimes, but for me, I like to set my working directory to a folder on my computer where the data is located. So I usually save everything in one folder, and I set this as my working directory. This makes just life easier when you're importing data and when you're saving things. Sometimes you want to save part of a data set or a plot or something. And then if the working directory is set, it's just so much easier. Then you know everything goes to the same folder.
Sorry for interrupting.
Yes.
So it is important that your data and your Python, your PY files must be in the same location.
Yeah, that's what I prefer to work with. Yes. And if you set your working directory then as that folder, you are set to go.
Yeah. And unlike other software packages, Python is quite happy if you use a Google Drive or something like that.
Yes.
It doesn't have to be on, it doesn't have to be on your device. I know some software packages, it's better not to go into the cloud and just stay on your own device with the files. But I see there you have a G drive, which is usually then a Google Drive.
Yeah, so just for clarity, this G drive is folders on my computer because I have Google Drive for desktop installed on my device. So it's like a folder on my computer.
Okay. Yeah. So just so that it's clear, yeah. I've had questions about that in the past also.
Yeah. So you use this os.chdr. So this stands just for change directory. It comes out of this OS package. Okay, so that's why it's OS dot. And then we give it the file path. So you can just go to your folder where it's located on your device and copy the file path and paste it in here. Okay, so it's important that you change this to where the data is located on your device. Otherwise, it won't find it. This is my file path. Right, so let's just run everything there. Okay. So when we import the data, so the data that we gave you is this racing game data. Okay, so that's also on Canvas. So you can download it from there. It's a CSV file. If you're unsure about your settings on your device on Excel, please don't open this file on your device. Rather import it to Python and work with it from there. Okay. A CSV file will automatically open in Excel, but if your settings on your device, the Excel settings is not correctly set, which is in most cases, then it might cause some problems with how you see the data. So rather don't open it in Excel, just import it to Python and you can work with it from there. Okay, so how we import the data. So we use this function read_CSV that comes from the pandas library. So we extract it from this PD. Okay, so we use the alias because it's shorter. And in inverted commas, because I have set my working directory, I can just specify the file name and the extension. So the file name is racingamedata.csv. That's the file extension. I import this data, but when I import it, I have to save it as something so that I know or so that I can use it again. Okay. So I import it as racing. So when I've imported the data and I start using it, I just use racing. Then that's what we're referring. Then Python knows it refers to the data. Okay, so let's import that. So if you look at, I'm just going to clear my environment first. Sorry about that. Then I'll import the data. So if you go here on the right-hand side on Spider to the variable explorer, and you double click on racing, you can see the data set that has imported. So there's multiple variables and observations. So each row is a game that was played by someone. There's a track, so there were different tracks that they could race on, different engines for the cars that they could choose. Then there's finish time, the top speed, and etc. and so on. Okay. So it's always nice to just have a look at the data, see did import correctly. Yeah, you don't have to stare at this for very long because we are going to start working with this now and summarize. But it's always nice just to check that everything has imported correctly. So first, let us just get a handle on the data itself. So we can obtain a list of variable names that's included in the data set. So we do this by using the list function. So we just say list racing. Okay. And if we run that line, you can see that we actually get a list of all the variable names included in the data. Okay. This is sometimes handy if you just want to remind yourself what the variable is exactly, because it has to, when you want to use the variable, it has to spell exactly the same. So it's sometimes handy just to quickly look again at the variable names instead of printing the entire data set. Okay, so this is quite one of the things that I quite use a lot. Right. So then we can obtain the number of of observation, so the number of lines, rows in the data set. So this function or way of doing it, so racing dot shape. So sometimes you apply the function at the end, and sometimes you put it in brackets. Depends on what you're doing, the structure there. So if you say racing dot shape, okay, if you just do that, it gives you two values, where the first will always be the number of rows, and the second will always be the number of columns. Okay, and you can see that this value actually corresponds to what is included in my variable explorer. Okay. So you can extract the number of rows and you can extract the number of columns. So the number of rows is the first object, the number of columns is the second object. Right, so as you might know, in Python you start with indexing of 0. Okay, so to get the first value, you can just say racing dot shape, and in square brackets, where what we use to extract, we use 0 as the index. Okay, no, I pressed the wrong thing. Let me. Okay, so I just wanted the number of rows, so that is 1360. It's the same there. So sometimes it's necessary for you to extract that value, and this is what you're doing to do that. To obtain the number of columns, you want the second value. Okay, so this is racing dot shape, and then you extract the second value, which is index 1. Okay, so then you extract the second value. Right. And then a way of obtaining the data set, the data type of each column. So this is useful when you've imported data, just to make sure that Python read the data correctly, or that it sees the data correctly, because sometimes you need to make some small adjustments, which we are not going to focus on today. So to get the data types, you say your data set name dot dtypes. Okay, and that will give you a list of all the variables and the type of the variable, how Python in the background sees your variable. Okay, are there any questions up to here?
Renee, there was a question again regarding, if you scroll a little bit up to line 9, about the OS dot and what follows.
Oh, okay, the directory.
Yes.
Okay. Okay, I see. Okay, I see they asked. Just to explain it again. Okay, so in line 9, we are setting up a working directory. Okay. So we are using the OS package and this change directory, CHDIR function. Okay, from the OS package. Inside the brackets, you have to give it your file path. So take the data and this script, save it somewhere. Okay, so when you've downloaded it, you have saved it somewhere in a folder on your device. Okay, and that file where you are saving, it, that is the file path that you will enter here. Okay. So it's usually in your file explorer, you can usually just at the top, just where you can see the file, the folders, you just click there and copy the file path. If you have set up a project in Python, okay, it's usually not necessary to then specify the file path. As long as you can get your data in Python, that is perfectly fine. There's always many ways to do the same thing. This is my way of doing it. If you have another way and you can get your data into Python, that's also good. Okay. I see someone's asking me to zoom in. Do you want me to zoom in more to the code or to the console? I'm not sure how to make the console's code or text bigger. Sorry about that. Okay, I'll zoom into the code a little bit more. Right. I think let us continue. So, if you want to display the first few observations of the data set, sometimes that's just nice just to see that everything is good. If you don't want to open the entire data set, because if you print a data set in the console and it has 1,300 lines like our data set have, you can't really see anything. Okay, it's quite, let me show you. Okay, so it actually truncates a little bit. It doesn't show you all the rows, all the columns. So it's not very useful. So in some cases, you would like to display only the first few observations just to see what everything looks like. And for this, you use this head function. Okay. So you're using racing.head. And if you just open close brackets, it will display the first 5 observations. Okay. So here you go. Okay. So we have a lot of columns, so it will only display a few. But it shows there at the bottom, this is showing 5 rows and 10 columns. If you want to see more rows, you can specify the number of rows that you want to see. In this case, we say 10. So in the brackets, then you specify the number of rows. We specify 10, and now it displays 10 rows and 10 columns.
Renee, may I interrupt, please?
Yes.
I just saw now something that I completely forgot about because I'm not a daily Python person. Maybe you need to say something about it, or maybe you don't want to. If you look there at the first column where we start counting.
Oh, yes, yes.
I don't know if it's
I've
something
mentioned
that
it.
you were, yeah,
Yeah,
coming
I'll
later to
quickly
it.
mention it again. Yeah. Yeah, so remember that Python starts indexes at 0. So you'll see the first row is labeled with a 0. So it's index 0. So you just have to keep that in mind, especially when you start extracting rows and indexing, which we will get to now. So Python starts with indexes at 0, not at 1, like some other software packages. Okay. So now, if you want to extract a certain column or a certain variable, okay, which is something that we will do quite often, you can specify the data set. And again, square brackets is to extract. So we're extracting and we are specifying which column. So in this case, it was the one of racing tracks. Okay. So you have to make sure that you spell it exactly the same as it is in the data set. This case, if you forgot, it's easy to just quickly in the console type list racing and see how it was spelled. It was spelled like track. So we extract this column and we save it into another variable so that it's possible to use it later on if we want to. Okay, so if we run this, you can see that it made a variable with the same number of rows as the data set, okay, which is not surprising. Okay, and our tracks, you can either view it here, where you'll see all the different tracks, or you can, in the console, it will show you some of the observations. Yeah. Then something that you also might want to do is to see the unique values in a specific column. So in this case, we have different categories. We have different types of tracks. And we might want to see, okay, what's the unique values? Which tracks were included? What was the categories? Okay. Depends on what the question is. So way of doing it is we can extract the variable as we did above, okay? And we can apply this unique function. So we have racing track. That's the variable that we extracted, and we are getting the unique values. This is something that you might not do on numerical data, okay? Because it has much more unique values, but in a categorical sense, there's usually just a few. So let's see, and we're saving this to a variable called track types. So we are getting different types of tracks that the races were completed on. Okay. And if we review this, we can see that there's 3 types of tracks. It was the complex track, the oval track, and a straight track. Okay. And even in the variable explorer, you can see there was three different tracks. Any questions up to here?
I know there are 2 things. There are people indicating that they got 12 columns, not 10, when they use the racing.shape function. So there's a little bit upward, where we're looking at the number of observations. Yeah, so there were people that got 12 columns, not 10, which I cannot explain. And then somebody asked, could you also change the code to see more or less columns?
Okay, so I assume that is with this one. Okay, let me first try to answer the first one. If you're getting 12 columns,
but there are others that say they got 10. So
okay.
yeah, I don't have an answer.
Maybe it is something, yeah, I don't know. My suggestion will be to try to delete the data set and just download it again. Don't open it anywhere, and then open it in Spider.
Yes, don't open the CSV file in Excel or in any other software that could read it. Open it directly in Spider. Yeah, that's the one suggestion. Also, it might be that you ran some other code where there was some error. It therefore, when I say error, not coding error, but maybe the way it was named, that it then created additional columns for that object, racing. So racing was created as 10 columns, but later got added other columns. And that's now where Renee is busy doing extra things. For example, extracting tracks. Maybe that was coded in such a way that it could attach to the racing data frame.
Yeah, I'm not sure if
later coding that you're doing.
Yeah, maybe you ran the entire data set, because here at the bottom we did add new variables. So yeah, just start again from the top. Don't run the entire data set and then each line.
Yes, that suggestion has also been made in Slack chat as well. Do not run the whole file, all the code lines. Do step by step, as we are doing. Yeah.
Yes. Okay. And then the one of the different, can you change it so that it shows more columns? I've never changed it really, because you can look at it in the variable explorer. So you can just double click on this racing and you can look at all the columns from there. So it's easier to look at it in the variable explorer than the console, especially if you have 10 columns.
Just show maybe again, Renee, how you accessed what you just did. So
if you go to the variable explorer,
yeah,
and you double click on racing.
So it's a double click.
Yes, then it opens up the data set.
Yeah. And then another question that's asked is just, can you just maybe show how do you run just a single line in Spider?
Okay.
Instead of running a whole, like a group of coding or the whole coding, yeah.
So maybe I should just explain this briefly. I'm not sure what was done on the other days or what you guys know about this, but this hashtag percentage sign creates these little lines, okay, and that creates like cells in your code. So if I click so that my cursor is inside the cell and I press on my keyboard Control Enter, then it runs the entire cell. Okay. And if I highlight a row and I press Shift Enter, it will only run that line. Shift Enter. Okay. It runs just that line. If I'm in the cell with my cursor and I run Control Enter, you see it says run cell. So then it runs the entire cell. I can't remember if I had to set that up or if it was automatic. If it's not automatic for you, you can always just copy the code. If you want just to run one line, just copy it to the console and run it from there. Okay, I see there's I see there's quite a few suggestions there, and you can read in the chat. So everyone has their own tricks. There's more than one way of doing something, and that's the nice thing about learning from each other. Okay. Okay, so let's continue so that we don't run out of time so we can finish this before tea time. I really want to finish this before tea time. So let's go. So now we're going to extract just one row of a data set. Okay. So we are going to extract row 5. So we're doing this with this ILOC. So it's index location. So you use the ILOC when you have the physical index. Like we know we want to extract row 5, so we say it's row 5 is on index 4, so we use the index directly. Okay. So we have racing.iloc. We use the square brackets because we want to extract, and we have the number 4 because row 5 is index 4, because Python starts with indexing at 0. Okay, so when I run this line, it gives me all the values on row 5. Gives me the track, so all the variable names are here, and the observations are just next to it in that column. Okay. So row 5 had complex track, a Nightingale engine, and so forth. We can extract multiple rows. Let's say we want to extract the 5th, the 7th, and the 10th row. Then we can use the same function, this index location, with the square brackets, but then we give it a list. So in the square brackets, we give it all the indexes that we want to extract. So we want the 4th, the 6th, and the 9th index. And each one is separated with commas. So if we run this, see that it extracted 3 of the rows. So in this case, it didn't display nicely because we have 10 columns. That's quite a lot to display in the console. You can always just save this as a certain variable, extracted. And when you run this, it creates a variable in your variable explorer, and you can view it from there very nicely. Right. Are there any questions on extracting the rows? Yeah, I see there's a question, racing.ilock and racing.lock gives the same outputs. Okay, so that might be. So usually ilock is when you specify an index, and lock can be, will rather work when you have something else to extract. So you'll see when we subset now, we're going to use .lock. Okay, whichever one works, it's fine. There's multiple ways of doing something in coding. So as long as what you are doing is working for what you want, then it's fine. Okay. So with the subsetting, I'm going to show different ways. So as you see, there's three subsets here. So the first one, we are going to subset one column, and we're going to extract only one type of value, or subset based on one value from that column. The next one, we are going to subset 2 values from the same column. I'll explain as we go again. And in the third one, we are going to subset based on 2 different values. Okay. Or 2 different columns, sorry. We're going to extract on 2 different columns. And then obviously, there will be always something else as well. You can then just add on. If you want to subset based on the third column, you can do that as well. Whatever is suitable for your analysis. Right.
So now, yes, somebody was just asking about what if you want to extract a column. So, yeah.
Want to extract a column?
A column, yes, but I think you just answered
it. Okay, so if you want to, so let me just, before I start with the subsetting, just want to make sure. So are you asking, you want to just extract one column, like have it as a separate variable?
Belinda is typing, so we will now say yes. And I think that's what you just did earlier on, yes, where you had the
Yes.
racing tracks, the columns, yes.
Yes. So if you want to extract a column from the data set, you use this, what is in line 36. So you specify your data set, and then you specify which column you want to extract. You can save this into a new variable, or you can use this further on. You'll see that we will use this syntax quite a lot. So it is your data set, square brackets, and you specify the column that you want to extract.
And then just something else, because I was also wondering about it, and Dr. Google provided me the answer, that the difference between the iLock and the lock is, let me quote from Google, lock function selects rows using the row labels, whereas the iLock function selects rows using their integer positions. Like you will see, this is how you used it there, and
Yeah. So the reason why it will give you then the same value is because actually in the data set, the rows are indexed with the 0, 1, 2, 3, 4, with the number.
Correct. Yes, yes, yes.
Thank you. Okay. So the first subset that we are going to consider is when we are going to subset the data to only contain the races on the oval track. So we only have to consider one variable when we are subsetting, okay, which is the track variable, because in the track variable, the different types of tracks is saved. So we want only rows, only races where the track was oval track. There were different types of tracks. We want to extract some of the data. Okay. So we start with the racing.lock function, okay, because we want to locate these rows and we want to extract them. Okay. We use square brackets because we want to extract. Okay. We want to extract, and then now we have to tell Python, what do we want to extract? It knows we want to extract from racing, but what? Okay. So it's always rows, comma, columns. Okay. So rows first. We want to extract the rows where the track is equal to oval track. So where the variable track in racing, okay, so see how we use that code where how we extract it, how we're using it again. Okay. And we are saying that has to be equal. So the double equal checks equality, and it has to be equal to oval track. Okay. And this has to be exactly spelled as it is in the data set. Otherwise, it won't be found. This is where that unique function that we did here on line 39, where that will come in handy just to quickly check in the console. Okay. So this is how we specify the rows that we want to extract. Okay. Then the columns, we want all columns. So we don't specify something, we just put a column. And it will extract all the columns. Okay. Let me run this. And we are saving this. Before I run it, let me just say that I'm saving this into a new variable. I'm creating a new data set called racing oval. And I am running that. And you can see a new variable created here in my variable explorer with 446 lines. And if I open it, it just shows it has all the track as oval track, because we subsetted the data to only contain oval track. Is this all clear? If you have any questions on this one, just let me know, because the others follow quite easily from this. So I'll make sure that everyone is on track with this question. Okay, so there's someone in the chat saying, so could we also, okay, so the code that you have there, you're asking if you want to specify column and row. So the code that you have looks like you're on track to specify to do what we're going to do in the third subset example. Okay. So I'm not 100% sure what you mean, what you want to do. Yeah. You can always, if you're unsure, you can Google, or you can just try it and see what works, what error you get. Okay, I see some people are asking, why is it starting on index 1? Okay, so in this data set, this index is the row labels. So from the original data set, this was row or the row labeled 1. So we extracted some of the rows. So it just kept those row labels. Okay. So when you're working with the index of this row, purely with ignoring the row labels, this will still be index 0. Okay. This is a row label. That's why it's index 1. Okay. Yeah, I see someone is asking if I can explain it again. I will quickly go over this again. And then I will continue to the rest, because it's the same concepts. Okay. And then there's someone that asks if we cannot change this to track, okay? Because we have already extracted that column into the variable tracks. My suggestion will be try it. Okay, I'm sure it will work because it is the same. You've already extracted it. Don't be afraid to try something, get your hands dirty, see if it works. Okay. Right, so let me go over this line again. So we are subsetting the data to only contain the races on oval track. So we have racing.loc, the location. That's the function that we're starting with. We want to extract, so we use square brackets. Inside the square brackets, we have to specify which rows and which columns to extract. So it's always rows separated by a comma and then columns. Okay. So as first, we want all the rows where the track is equal to oval track. Okay. So we extract the track variable from the data set. We want to extract where it's equal to oval track. Okay, so remember this oval track has to be spelled exactly the same as how it is in the data set. Okay. And we use a double equality sign because that is to check equality. Just equal is to assign. Double equality, we are checking whether something works or whether something is equal. And then we say comma. And which columns do we want? We want all of them. So we just put a colon. Don't have to specify which columns we want. Right. I hope that is clear. I'm going to move on to the second one. Okay. Yeah. And then, because it's in the same flow. So now we want to subset the data to only contain the races on either the straight track or the oval track. So we are still subsetting based on one variable, based on the track variable. But now we want straight track and oval track. So we want two of the categories in the same variable. Okay. So what we do here is, again, there's multiple ways of doing it. Okay, you can, there might be a different way. This is how I've done it. Okay, so I first specify an array with the category labels in, with the track types that I want. I want straight track and I want oval track. So I save this in an array. So I create with my square brackets and separate it by a comma. Okay, and I save this into the variable tr. Very creative. It's just the first two letters of track. Whatever you want to call it. Okay. So now I'm starting to extract from racing. Okay, so I use racing.loc.location. I'm using my square brackets because I want to extract. And then I'm using racing. So I'm saying racing track. I'm extracting the track variable. And I'm saying that the values in track that I want, that I want in my data set has to be in it. So I say I applied this dot is in. It has to be in this variable that I just created. It has to be in there. So this will extract all the rows in the data set that has a track, the value in the track variable is equal to one of these values. So it can be either straight track or it can be oval track. Okay, so it's an or. So it has to check whether it's one of the two. Okay. And that is the rows. And then again, I want all the columns. So I use a colon to say, I want all the columns here. So I use a colon to specify all columns. Okay. I'm going to say that again, just to make sure everyone's on the same page. I want to subset data to only contain the races on either the straight track or the oval track. So I want to subset the data sets based on a single column. But this column can either be straight track or it can be oval track. Okay. So I'm creating a new variable with an array specifying these two categories. Okay. You can specify it straight there. It just feels neater for me if you specify it separately. So I specify a new variable where I create an array with the categories that I want in. So I want straight track and I want oval track. Okay, let me run that. So I create that. Now I want to extract from my racing data set. I want to extract. So I use racing.loc and I start with square brackets. And then I have racing track. So I extract the track variable. I'm working with that. I want to check a condition there. And I want all the rows where the track variable has the value that is included in this array. So where the track is either straight track or oval track. And then comma, so that's the rows that I want, and the columns, I want everything. So I just say colon. Okay. So I run this, and you can see now I saved the new data set in racing oval straight. So in my variable explorer, I now have a variable racing oval straight, which is a data frame with 865 observations, rows. Okay. And if I run, if I open this, you can see that track has everywhere oval and straight track. It's just those two that's in there. Oval and straight track. Right.
And the interesting thing, Renee, is that with the index, it actually doesn't do 0, 1, 2, 3, 4, 5. It goes and tells you the specific from the original data. That's very nice.
Yeah. Yes, because this is the, it's actually like a row label.
Yes, yes.
Right, so let's do the last subset example before we, let me just see my folio. Not that far. Don't finish with the script. Okay. So we are subsetting the data to only contain races on the oval track and the car that had a Bayes engine. So now we are subsetting on two things. We are subsetting on the track and we are subsetting on the engine. So the track has to be oval track and the engine has to be a Bayes engine. So we're subsetting based on two columns. Okay. So here goes. So it's just building on what we have done. So again, we subset with racing dot the location, and we have square brackets, right? And then we go to the first column that we want to extract, which is track. So we want to extract where track is equal to oval track. Okay, that's what we had in this first example. It's exactly the same. Now we just add something. We want to say it has to have oval track on track and Bayes on the engine. Okay, so we say the oval track, and now we use ampersand. So some programming language have something else that you have to specify. In Python, it is the ampersand, this symbol. Okay. So and engine, so we extract engine has to be equal to Bayes. Okay, so again, we use the double equality signs because that's how we want to specify that we want to check equality. Okay, and we have two conditions. So we have this condition and this condition has to be true. So this is the first argument in the square brackets. So that's the rows. And we have comma. We want all the columns. So again, we have colon. Right. So if we run this, we save this as new variable racing oval Bayes. And if you look in your variable explorer, you have a variable with or a data frame with 150 rows and 10 columns. And if you open it up, you can see that it's all oval tracks and Bayes engines. So it did the subsetting correctly. It's always important to check as you are going that the code that you're writing actually gives you what you expect. Okay, don't write the entire script and then try to start debugging. Go as you go, check that the code is actually doing what you want it to do. Okay. Are there any questions on the subsetting?
No, I'm scrolling, but I think most of the questions have been answered, but if not, I'm scrolling through the chat because fortunately, this is what's very nice. I thank everybody for replying on our behalves in the chat line.
Yes, it's very nice with this type of chat because it gives you guys also an experience or an opportunity to learn from each other. And sometimes there's code or something that someone adds in the chat that is something new for us as well. So it's always nice to learn like this. Okay, if there's no questions that I missed, if I missed anything, please just post it again, or if someone can just alert me on that. But otherwise, I think it's tea time in 4 minutes.
I think this is maybe the good place to break it, Renee, unless you want to steam ahead.
Yes, maybe, you know, let me just talk about the sort, and then because that's it's quite easy.
Okay.
And then if there's questions, then I will answer that after tea time. Yeah, we don't have that much left. The rest is going to be quite quick.
Okay, that's fine.
So let me just quickly do the sorting, and then it was the subset that usually takes quite some time. So in some cases you might want to sort the data sets. So I'm going to do 2 examples. So one where you sort the data sets based on one variable. And then I'm going to do one where you're sorting it according to 2 variables. Okay. So the first, we're going to sort the data set by top speed reached. And we're going to do this in ascending order. Okay. So we are specifying the data set racing dot sort values. So we use the sort underscore values as that's the function. And then in the brackets, we are specifying the by argument. Okay, so there's different arguments for this sort underscore values. And the first one is by. So this one tells you by which column should it sort. And in our case, we want top speed reached. So we specify the column in square brackets in an array, in like an array. Okay, even though it's just one value. Okay, so we have racing dot sort underscore values. In the round brackets, we have by, that's the argument that we are going to specify, and we are specifying with this argument by which column should it be sorted. Okay. So the column we specify with the array, and even though it's just one column that we specify, we still use the array, and it's top speed reached. So if we run this, so we save this into a new variable racing underscore sorted. Okay. And in the variable explorer, there is my variable. And you can see that top speed reach is now in ascending order. So the smallest value is at the top. And as you go through the data set, you can see that this value gets bigger and bigger and bigger. And also now this row labels are shuffled. Okay. So that's how we sort by one column. Okay. So I see it is 11 o'clock now. So after tea time, I will then start with how we sort by 2 columns. Okay, if you have any questions, please feel free to still post them in the chat. And then, yeah, let's take the tea break, and then we will continue at 11:15, if I'm not mistaken.
Yes, Vinay, thanks. You are correct.
Okay, perfect. See you guys at 11:15. Okay. Hello, everyone. I hope everyone had a good tea break. I'm not sure if everyone is back yet and ready to start. I see there's thumbs ups on the message saying everyone ready. So let us, then I'm not going to delay. Let us start so we can get through everything before lunch and then spend this afternoon on some nice exercises. Okay. Okay, so just before the tea break, I stopped. I stopped at this line 64. So we sorted the data set by top speed reached. Okay. And then the next sorting that we're going to do is we're going to sort the data set by top speed reached. We're going to do that in ascending order. And then we're going to sort by finish time in descending order. Okay, so now we're going to sort by two data sets simultaneously. So usually how that works is the first data set is sorted first, okay? And where there is duplicates, like the same value for top speed reached, then those rows will be sorted by finish time. Okay. So we again use this racing.sort underscore values. So we again use that function. And now we are again using the by argument. And we are adding both columns that we are sorting on. Okay. In an array. So we're sorting on top speed reached and on finish time. Okay. And we separate this with a comma. So we specify both columns. Then, in the next argument for the function, we use the ascending argument. Okay. So now here is the argument where we specify if we want ascending or descending. Okay, if we don't specify, the default is ascending as we had at the top. Okay. But now, the one column we want to be sorted ascending, and the second one we want to be sorted descending. So we have ascending is true. So we specify it also in an array. So the first element in the array will be for the first column that we're sorting on. So we want ascending equal true. So we say true. And then the second element in this array corresponds to the second column that we're sorting on. And we want that to be sorted descending. So we say false. In Python, the true and the false is written as the first letter capital and the rest lowercase values. Okay, so let me just quickly say that again. So we're using the racing.sort underscore values. We are specifying the by argument, and we're specifying in an array the columns on which we want to sort. We want top speed reached and then by finish time. And we are specifying the ascending argument, again as an array. So the first element corresponds to the first column, and the second element corresponds to the second column. So the first one we want in ascending order, so we specify true. And the second column we want in descending order, so we specify false. Right. So we can actually run this. So we save it into a variable called racing sorted 2. So we are running that. And in the variable explorer, we can look at the data frame. So it's first sorted according to top speed reached. Okay. And then to finish time. So top speed reach will be in ascending order. So the smallest value will be at the top. So it's first according to this. And here you can see there's two values with the same top speed reached. So then those two rows will be sorted according to finish time in descending order. So the one with the greatest finish time will be first and then the next. Okay, so that's how the sorting works. Right. So the next part that we're going to do, we're going to remove one of the columns and we're going to drop one of the rows, or drop some of the rows. Okay. So first we're going to remove one of the columns. Okay, so this you usually do when you want to clean up the data set a little bit, where there's columns that you're not necessarily going to use in your analysis, and you want to rather than remove them to not keep dragging them along. Okay, it depends on the situation. You can keep them, but sometimes it's neater to drop them. Okay, so you use racing.drop. So racing your data set, and you're going to drop the column. And you specify which column you want to be dropped. And with this access argument, you are specifying that it's actually a column that you want to drop. Okay. So we use this dot drop to remove an entire column. And if we run that, you can see racing 2 here in my variable explorer now has 9 columns because I removed one of them. Then let's remove, if we want to remove, let's say the last 10 observations. We can do this by subsetting my data set or extracting from my data set. And we use the square brackets. We use the square brackets because we are going to extract. And we want all the rows except the last 10. So this is a way of specifying. It's one way of doing it. Okay. So you can specify the indexes and say from this colon to the next, or if you specify it like this, just colon minus 10, it's going to take all the rows up to the last 10. So it will remove the last 10. Okay, so this minus counts from the back. So that's actually a quite nice feature about Python, that you can use minus indexes to save the last 10. So this one will reduce or remove the last 10 observations. So if we run that, in my variable explorer, you can actually see that there's 10 less rows in this new variable. So I see someone asked, why would you want to remove the last 10 observations? So for this, it's just an illustration on how you will do it. Depends on your analysis. Sometimes you want to remove some of the observations. It might be, yeah, one way of subsetting as well. Maybe.
Yes, what I was just thinking of subsetting. Sometimes you want to divide a data set into a training data set and a test data set, and maybe so you want to remove part of the data for your training data. So why I'm mentioning that, what Renee is very cleverly doing here, and I suggest always do it this way, she each time gives a new name. She's basically, may say, oh, but why so many data frames? But you don't want to overwrite a data frame ever. So because once you've dropped observations, they are gone. So racing 2 is not, you still have the original racing data frame as well available. So I think that's a clever thing just to point out, Renee.
Yes, yes. Yeah. It's never a good idea to overwrite something. Okay. There's some people asking code. So the question that just came in, that access equal 1, that just specifies the columns. And I believe access equals 0 specifies rows. Okay, that was also a question. Then there's a question on the sorting. I'm not 100% sure if I'm understanding your question. I'll have to run that code physically. But your code is correct, so it should work. Maybe just I can't believe that Python has a preference. Yeah, I'll have a look at that just a little bit later. Let me. So you can if you want to drop certain rows, I haven't included it here. Try to see if you can find something nice that works on Google. You can also subset like some of the observations, like let's say the 10th to the 20th row, similar to something like this. Yeah, see if you can get your hands dirty and explore a little bit. Maybe if you just even just try something new, so maybe surprise yourself and figure it out. Or with but yeah. Okay. So in the next part, we are going to do 3 examples of creating new variables. So different ways of creating new variables. Of course, it will be very specific to your application. But so this is an example, and again, we're giving you the introduction to just make you a little bit excited on everything that you can do. Not everything, like just a snippet, because there's so much that we can actually also share. So yes, so the first one, we're going to create a new variable in the racing data set, we're going to call it checkpoint 122, okay, which will contain the time it took to go from checkpoint 1 to checkpoint 2. Okay, so let me just explain what we are trying to do. So in our data frame, we have a variable called checkpoint 1, and we have a variable called checkpoint 2. And we are, so this variable is the time that it took for the individual to go from the start to checkpoint 1. Then checkpoint 2, that variable, is the time that it took for the individual to go from the beginning to checkpoint 2. So now we want to know, how long did it take to go from checkpoint 1 to checkpoint 2? Okay. So how we are going to do that is we are just going to subtract the two times from each other. So we're just going to extract checkpoint 2 from checkpoint 1. And that's how we're going to get the new variable. So we're doing a numerical calculation, a very simple one. So how we are creating a new variable? So we can start the line, how we would assign a variable. We can just say racing, which is our data set. And in brackets, as you would extract a variable, just extract and just put your new variable name in there. So we're actually creating a new variable very subtly by just putting it there. Okay, just assigning the variable. Okay, so this is my new variable name in racing. And what should be in that variable is checkpoint 2 minus checkpoint 1. So I extract checkpoint 2, and I'm extracting checkpoint 1 from racing, as I did before, and I'm just subtracting it from each other. Okay. So and then that value is saved in a new variable called checkpoint 122. And if I run this, so this will make a change to my racing data set. Okay. I'm adding something so it's less dangerous. So if I look at my data set now, I have a new variable called checkpoint 122, and it's the difference between checkpoint 2 and checkpoint 1. And you can actually go and check it. It will be correct, those values. Right. So the next way that we can also change variables. So in this one, we actually have a category. So it's this checkpoint 2 underscore 66 variable in your data set. Okay, it's this one that contains ones and zeros. So it contains a 0 if checkpoint 2 was reached within the first 66% of the race. Okay, it's a 1 if it is reached within 66%, and a 0 if it's not reached within 66%. Okay. So we want to recode this variable to contain the words yes and no instead of ones and zeros. So we are going to say, so if it is a 1, the value should be yes. If it's a no, the value, or if it's a 0, the value should now be no. Okay. We're going to do this again with the exploratory data analysis. So if you don't get it 100% now, I am going to repeat it when we go to the exploratory data analysis. So to do this, again, there might be multiple ways to do this. I prefer this way. So we are creating a dictionary. So in Python, a dictionary is specified with curly brackets. Okay. And it basically, what does a dictionary do? It gives you explanations of words. So now we're going to give it explanations to values. So you say 1 means yes and 0 means no. And we save this dictionary into a variable to replace. There we go. Okay. And how do we change this now? Okay. So what I'm doing here might be dangerous. So you should always make sure that you have tested this before you make changes to your data set, because I'm going to make a change to my data set now. Okay. Luckily this code is tested, so we can run it. But before you make a change to a data set like I do here, make sure that the code does what you want it to do. So first save it, or first assign it to another variable called test or something. So I want to replace, so I'm overwriting. It's dangerous sometimes if your code is not tested. Okay. So I want to make a change to this checkpoint 2_66 column. Okay, so I'm extracting that and I'm going to assign the new things to it. Okay. So with the dictionary, it's very simple to recode the whole variable. So I'm taking the variable name that I extracted and I'm going to replace it with what's in the dictionary. So I say dot replace, and in the brackets, I'm specifying the dictionary that I gave you. So this line of code will change all the zeros to no and all the ones to yes. So if you check here, it has 0, 1, 0, 0, 0. So this will be, if we change it, it will be no, yes, no, no, no. Right? So if you run this, let's see. Everything is changed. It's no, yes, no, 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 yes, yes. Okay. So it changed all the zeros to no and all the ones to yeses. Good. Right. Okay. So okay, the last one that we're going to create, we're going to create a new variable in the racing data set based on finish time. Okay, so now we are again creating a new variable. So we want this variable, if finish time is greater than 25, we want this new variable to display slow. If it's less than or equal to 25, we want the new variable to display fast. Okay. So the easiest way to do this for me, okay, there might be other ways. If you can find another way, it would be lovely if you can share it with us. We are going to create a function that checks whether the time is greater or equal or greater or less than 25. How we create a function in Python, we use this def, D-E-F function, okay, or argument. Then the next one is the function name, and the next one is the arguments, okay, what's used in the function. Okay. Then we start with a colon, and it's indented. The moment that the indent goes back, Python knows that the function stops. Okay. So that's the way Python works. And then we check. If the time, what we are giving to the function is greater than 25, this function has to return the word slow. Otherwise, it should return the word fast. Okay. So if the time is greater than 25, it returns slow. Otherwise, it returns fast. Okay. So now we create our variable. So we have the indicator variable. So we wanted to have it called, I didn't specify what we wanted it to be called, but let's call it indicator. So again, we subtly just create it. Just specify, okay, it should be there. Okay, and assigning something to it, and then Python knows what to do. So you say racing indicator. We want to use the finish time variable. So we're extracting from racing from finish, or finish time from racing. And we are just applying this function to that entire column. So we say dot apply, and we specify the function. So then it will create the slow fast in the indicator variable based on this finish time variable. So let's run this cell and see what's in racing. Okay. So it created a new variable with slow and fast. Let's just drag this a little bit bigger. So you can see finish time is greater than 25. So it says slow. The second one, finish time is less than 25. So it says fast. So it works, does what we want it to do. Okay. So just recap, we created a function that checks whether a value is greater than 25 or less than 25. And we took this function and we just applied it to that entire row. Okay. That's what we have done here. Okay, so I see there's someone that says the dictionary has some time advantages in it. I believe so, because it works faster than if statements, I'm sure. And then, but if you can get it done on another way, you're more than welcome to try it and share the code with us, so that we can all learn, if you can get it right in another way. There should be another way to do it. Then can't we use the dictionary instead of the function? I'm not sure how you're going to use a dictionary with the numerical variables. If you can get it right, please share it with us. But in my understanding, the function is the faster way, the better way to do it. Okay. And then yes, apply is a function that takes in another function. Okay, so we're applying a function. How does one interpret time here? Okay, so time, this variable time is just a placeholder. So it actually, so it says, with this function, you are going to supply it with a value. In this case, it's going to be the values in finish time. You're going to give it a value, and that value is going to be time. So everywhere where you use the word time in that function is that value that's given to the function. Okay. You don't have, you can use functions on other ways as well. But that's how time's like a placeholder for the value that you're giving to the function. Okay, and then I see someone did add another way of creating the indicator variable with a lambda function. And so lambda is another way of doing it. So that's quite well done. And thank you for sharing it. Okay. Okay, and I think the rest of the questions is fine, answered. Right, so let's just quickly do the last part of the data handling before we move to exploratory data analysis. Okay, so the last part is the duplicated values. So duplication can occur with when you have multiple people working on the data, mistakes can happen, or when you've maybe entered the same data twice with data entry step. But most of the time you would want to remove these duplicates. Okay. So we are going, first of all, just print the rows that's duplicated, and then we're going to remove it. Okay, so it's two different ways of doing it. So we are going to, if we want to print the data, so we just want to see which data is duplicated. We are using the racing.duplicated function. Okay. And we are saying, we are specifying the argument keep. Okay. So there's three possible values. You can look at the documentation for this function to see full details. You can either specify first or last or false. Okay. If you specify false, it's just going to show you everything. Okay, all the rows that's duplicated. Okay. So if we run this and we print duplicates, I want to show you what it does. It gives you true and false values. False, where the row is unique, and true where it's not unique, where it is duplicated. Then how do I get the rows that's duplicated? I'm going to just save this into a variable so that I can open it in the variable explorer. I can say racing, which is my data set, and I can extract the duplicated rows. So this duplicates, I can add in racing or extract racing. So then it's just going to extract all the rows where this duplicate variable is equal to true. Okay. So let's look at this data frame. Right, here we go. So these are all the rows that's duplicated. So you can see that this row, that these two rows are exactly the same. So that they are duplicated. And these two rows are duplicated. Okay, so that's all the duplicates in the data sets. And remember, I specified keep equal false, so it will display all the rows to me. Okay. Not just those that's double. And then just something extra, if I say the sum of that duplicates variable, because this duplicates contains true and false values, if I say the sum of that, it will give me the number of trues. Okay, so we saw there's 4 rows, so this should give me 4. Okay. And it actually does. Okay. If you want to see just the numbers. Right. And then the last thing of data handling that we're going to do is to remove the duplicated rows. But we want one of the rows should be kept in the data frame. One of the rows should be kept. So for this, we are using the drop duplicates function. So we apply this to the racing data set. Say drop underscore duplicates. But we want to keep one of the rows. So now with this keep argument, if we say keep equal first, it's going to keep the first of the rows, of the duplicated rows. If we say keep equal last, it's going to keep the last one. And if we say keep equal false, it's going to just chuck everything away. Okay. But we want one of the rows to stay. We want to remove those that's duplicate. So we say keep equal first. Okay. So if we run that, we can see now in the no dupes variable is a data frame where 2 rows are removed. Okay. 2 of the rows are removed. And this is because these are the duplicated rows that we had, but we asked it to keep one of them. So it kept this one and this one. So it removed the row 298 and the row 836. So it removed 2 of the rows. Right. Are there any questions? I don't see anything in the chat.
No, I also didn't see anything in the chat. But there are several people typing.
Oh, I see. I see someone asked me just to explain duplicates and the keep options. Okay, okay, so again, keep Just wait, I see someone else is typing before I go back to Python. Okay, let me start with those. Okay. So there's some duplicates that I did. So duplicates is an array of true and false values. So if I take the sum of such an array, it gives me back the number of trues. Okay. So that's what it does. It gives me back the number of trues. It's just a quick way to see how many rows were duplicated. Okay. Before I printed it. Okay. And then the keep argument. So this keep argument can take on 3 values. You can also look at the documentation for this function for full details. The first argument you can specify is first. So this means that when we are dropping the duplicates, it's going to keep the first row, the first duplicated row, in the data set. So that's the first one. The second one, you can specify it as last. That means that when it drops the duplicates, it's going to keep the last row. Okay, so it's going to keep one of the rows in the data set. If you specify false, it's just going to throw everything away. Okay. Just going to throw everything away. Okay. Then there's a question, does it apply to specific data types, integers or floats? I'm not entirely sure what you mean, but the duplicated values will, the duplicated function will just check for if the values are exactly the same. And usually in a column, everything is the same data type. Okay. Then there's a question, but we say keep equal false. Yes, that's the first one. So doesn't the sum gives us the value of false, the total of false values? So this sum duplicates is completely separate from this duplicated function. This duplicated function just gives us out a vector of true and false values. And I'm separately on the side just checking how many rows are duplicated. So I use that sum just to check how many were true values. Okay, remember I have 1,360 rows, so I can't go manually through all of them. So just want to check how many are there. Okay. So someone is asking, in terms of checking the duplicates, does it compare up to a certain decimal as a default, or is it flexible? As far as I know, it checks everything. It has to be exactly the same. And yes, duplicates are elements that appear more than once. So it's rows. So if you look at this dupes data frame, these 2 rows are exactly the same. They are duplicates. And these 2 rows are exactly the same. They are duplicates. So it's where the rows are exactly the same. Okay. Okay, so someone is asking what insights are we hoping to get from this data set? So there's actually, you can do some numerical inference on this data set. For our purposes, we are purely just using it now for illustration. Okay. Purely just illustration. Okay, so I'm going to go over to, again, just do my slides. Okay. Okay, so we did this exercise on data handling now. And I have a little exercise in this, so you all have access to this. It is on Canvas. I'm not going to do the exercise now. I'm rather going to go to the exploratory data analysis, and then this afternoon we will go through this exercise. So you'll be able to test or apply what we learned now and try it for yourself on a different data set. You have access to the code that we just went through. So you can see if you can get your hands a little bit dirty and explore a little bit. Okay. But we'll do this after lunch. So exploratory data analysis. So the goal of this is to simplify large amounts of data in a sensible way. With this step, we don't draw any conclusions about data that we're analyzing. We don't reach any conclusions regarding hypothesis. We don't try to infer characteristics of the population. We are just trying to present our data, quantitative descriptions of the data in a manageable form. Okay. We are simply trying to describe the data. And this is the start and the basis of every quantitative analysis. Okay. It's where you start with statistics. So categorical data. So as we have said before, we said it earlier this morning, it's like categorical data can be eye color, it can be ratings from 1 to 5, it can be marital status. It's everything that has categories. Okay. So there's different ways of summarizing this data. And numerically summarizing, we usually use frequency tables. Okay. And with a visualization, we will use something like a bar plot or a pie chart to visualize categorical data. So a bar plot is the more popular one between the two. And a bar plot has these bars, but it's always, it has spaces in between. Okay, it's not, the bars don't touch. Right. Then when we get to numerical data, that's like anything that you count or measure. Okay, so number of cars, that's a numerical data. Or something that you measure, height, length, weight, temperature, something that you measure, it's numerical data. Okay. So numerical data can be described in numbers in different ways. Okay, so we actually split it up into two categories. So descriptive characteristics on the location of the data. So where does it lie on the number line? So for that, we usually use mean and median, okay? And 5 number summaries. So 5 number summaries is like the minimum first quartile, second quartile, third quartile, and the maximum, okay? And then descriptives on the variability of the data. That is something like the standard deviation or the interquartile range. Okay. So that will give you an indication of how spread is the data, how far it's spread. Okay. And then for visualization of numerical data, we usually use histogram, which is similar, it looks similar to a bar plot, but in this case, the bars actually touch. Okay, it actually touch. And it divides this numerical variable into categories. Okay, and then it counts the number of values in each category. Okay. And then the box and whisker plot, the second one. This is something that you might be familiar with. Okay, so it's actually a visualization of the 5 number summary. So we have this box, which is the first of the middle 50% of your data. So on the left-hand side, it's the line where your first quartile is. The line in the middle of the box, that's your median. And the line on the right-hand side of the box, that's your third quartile. And then these horizontal lines, which is the whiskers of the plot, that stretches out to the minimum on the left and the maximum on the right. And whenever there's dots, that's something that we call outliers. And then the other way is a scatter plot. So that's usually when you have 2 numerical variables that you want to compare. So you have plots or dots, okay, indicating the value of the x and the y, so the 2 variables. Okay. So that's briefly like ways of summarizing your categorical and your numerical data. So for this, we're going to look at a different data set, which is the Pick and Pay animal cards. So I'm not sure if you're familiar with it, but Pick and Pay at some point gave out cards if you spent a certain amount of money, and these cards were collectibles. But it was animals, and all the cards had information on the animals. Okay, so we have a data set of all these cards, and that's what we're going to do. So we're going to explore a little bit on that data set. So again, everything that we do here is for illustration purposes, right? So we're not doing any inference at this point. We're just going to get familiar with this data set. Okay. So we're going to go back to Python. I'm going to clear my environment just so that we can start off on a clean slate. Okay. Okay, so you should have access to this Python script. It's on Canvas, so please quickly download it and open it. We had a little practice when we did it this morning with the data handling. Okay. Yeah, if you can access that. There's some things that I've already explained in the data handling. So I'm not necessarily going to go over it again in that much detail. Might quickly say something. So yeah, so there's some things that I might just browse over. Right. So for this script, we need the following packages. So again, we need pandas so that we can work with the data. We need NumPy, okay? Might only come at the end. This, we give it an alias NP. Okay. And then we have two packages for the data visualization, matplotlib and Seaborn. Okay. I prefer Seaborn, or yeah, doing the plots. You can do it in matplotlib as well. But whatever, there's more than one way to do the coding. Okay, so the matplotlib, I'm importing the pyplot from matplotlib, and I'm going to give it the alias PLT. Right. And then in Seaborn, I'm giving it the alias SNS. Okay, so mostly the aliases are quite standard. And so everyone uses SNS and everyone uses PLT or whatever. Right, and then I'm just changing my working directory again. It should still be good or the same as if you set it this morning. Remember, there's multiple ways to do it, whichever one you get. Okay. So I'm just running it. And again, I'm importing my data. In this case, it's called super-animals.csv. So again, you can get this data set from Canvas. And you please don't open it in Excel or something that wants to open it. Import it directly into Python so that you can avoid any problems. Okay. And I'm using the read_CSV function that from the pandas data, from the pandas package. Okay. And I'm saving it into a variable called animals. So if I click on animals from my variable explorer, you can see actually what is included in the data set. So you have the animal name, the category, the species. We have age, weight, size, speed, vulnerability, and another variable updated. Okay. Then these three I'm not going to go over again. We can obtain the variable names. I'll just run it. The variable names, all there. The number of rows, okay, which should be 108 because we can see that from the variable explorer. And the number of columns, which should be 10. Okay, we've done this in the data handling section as well. Okay. Then we are going to draw a histogram of the size of the animals. So let's start. So that's the first exploratory data that we're going to do. So size is a numerical variable, so you can draw a histogram. Because size is measured in centimeters. So we can use this histplot function from Seaborn. So the arguments that you give it is you can say data equal animals, and the X variable is size. Remember that this has to be spelled exactly as it is in the data set. If I just run this, so if I just run the histogram, okay, and I open my plot, this is what it looks like. Right. But now I can make changes. I can change the color. I can change the number of bins, whatever. Okay. So I can change it as I like. And I can add labels. So if I want to change the color of the bars, I can specify the color argument. And I want it light blue. And then the edge color of the bars, you can also change. And I want it blue. So I specify the edge color argument as blue. And if I decide I don't like these lots of bins, I can also change that to bins equal 10. Let's say we want 10 bins. Okay, so let's just run the histogram. And that's what it looks like now. See, I changed all these colors and I have less bins now. Okay, you can, let's make it 20 and see. You can see it makes more bins now. Okay. If I want to change the labels, let's say I want to change the y-axis label to frequency instead of count, and I want to give my plot a title. This is what I do. So I have to set the plot to a variable called size, right? And so I set this to size, or to any name that you want to give it. And then I have to set. So then I'm going to say size, that variable, and I'm setting my options. So in this case, I want my Y label to be frequency, and I want the title to be histogram of the size in centimeters of the animals. So the title should just be something descriptive. Okay. Remember, a plot, you have to be able to give it to someone and they should be able to understand it just by looking at it. So the labels should be descriptive. And then I specify plt.show just to say, listen, please show my plot. Okay. Otherwise, it's not going to show because we have set it equal to a variable. We've assigned it to a variable and we made changes. So we're saying we have to specify that it should be showed so that Python knows we are done with setting the settings now. So if I run this, this is the result. Okay. So I have nice heading and I have my frequency as my Y label. Okay. So yes, Seaborn works hand in hand with Matplotlib. Okay. I see some of the questions is answered that you have to install the package Seaborn. Yes, that might be necessary if you have to.
Yes, and then something that you maybe have to just explain a little bit is in terms of where the plots appear.
Yeah,
in the
so
environment.
So my plots appear. I think if you have a problem with the setting, I can't remember how to change it, because some devices might plot it somewhere else. But on the right-hand side, next to Variable Explorer, there's link for, or there's a place for plots. So if you go to plots, it will display there. And then I see there's someone that says, not to throw a span in the works, but I find R packages like ggplot makes much nicer figures. Is there any benefit to using Python instead of R? So again, it depends on what you want to do. If you did your analysis in R, you want to make your plots in R, you can do it. So for everything that I'm showing here, it's for illustration purposes. So if you want to make your plots in Python, this is how you can do it. So I see some of the questions are answered, and I'll quickly go over to how to draw a histogram again. Okay. So I'm going to explain everything now in one. I'm not going to break it up again. Okay, so you can use this sns.histplot function, okay, which is from the Seaborn package. Then the data set is animals. So we specify that as the data argument, and we just have to give it an X variable, just one variable, which is size. I can specify the colors of the bar and the edge colors of the bars, right? And I can explain the number of bins, or I can specify if I want a certain number of bins. So how many bars I want. Right. So if you just want that as your default, you can just have that. But I want to set labels. I want to change my Y label. I want to change my title. So I can say, I can save this into a variable called size, so that I can now change my settings. So now when I want to change my settings, I extract this variable and I say .set. Okay, and now I specify the settings that I want. So I want my Y label to be frequency, and I give it a nice title. Anything that you want, as long as it's descriptive. And then I specify plt.show, so that I can alert Python, listen, my plot is done now, or my setting is done now. You can plot my plot. Right. Right. So next, what we're going to do is we're going to draw a frequency table. So a frequency table is for categorical data. And so let me show you what it looks like. So if we do a frequency table, we can save this table into a variable. In this case, we called it species, because we are going to get a frequency table of the species variable in this data set. So we say animals species, we're extracting the species variable. Remember how we did that in the previous example as well. And to get the frequency table, we just say dot value underscore counts. Okay. So if we do that and we say species, so we print species, we get a frequency table. So we get all this categories in the species variable, and then we get the counts. How many values or how many observations were mammal? How many were bird? How many were reptile? So it gives me counts. And that's a frequency table. Okay. What we can also do is we can calculate proportions in this frequency table. So instead of having a count, you'll have a proportion. So it will be the number of values. So it will be 49 divided by the total. Okay. So we do this exactly the same as we have done the frequency table. But now in this value counts function, we have the argument normalize equal true. And that will give you the proportions instead of the counts. So if we run this line, we have species underscore proportions. And you can see now we have proportions. So a proportion is a value between 0 and 1. If you multiply it with 100, you will get a percentage. I see someone asked how we're going to get the average and the standard deviation. I'm getting to it. Okay, so we will get to it. Okay, so a bar plot, remember a bar plot is one of the visualizations of a categorical data. So we can again use the Seaborn function, and this time it's bar plot. Okay. For a bar plot, we first have to get frequency table. So we are going to use this frequency table that we created in our bar plot. Okay. So as our X values, we're going to say species dot index. This is the labels in the frequency table. And for the Y values, we are going to take the frequencies, the actual counts. So that's the species dot values. So the X and the Y. And again, as we did with the histogram, we can again set our labels. So you can set as Y label, we can set an X label if we want. Usually that's automatically quite nice. And we can set a title. So this is the syntax is the same of the rest. It's just this bar plot that's different. Okay. So there's the plot of a bar plot of the species. Okay. So you can see in the frequency table and in the plot, because we use the frequency table for the plot, it's automatically the category with the most species or the highest frequency first, and then it goes down. Okay. Just see if there's any questions. Yes, you can change. I see there's a question. Can you change the properties of the bar plot? Yes, you can change it. Yeah, go see what's the arguments for bar plot. And if you can give it different colors, yeah, go and play around a little bit with the functions and see what you can come up with. Okay. So the next thing that we're going to do, just see. Next thing that we're going to do is two-way frequency tables. So that's when you want to get frequencies of two category or two categorical data cells. Okay.
Quickly, sorry. I clicked something funny on mine. I wanted to say something. Obviously, when you did the histogram, the earlier plot that you made, it's easier there to just change the color. But the one you just did, I would think color schemes is what you need to look at. And I'm not sure, to be honest, how to do that in Python. But it's not just that you want to, I don't think you want to specify each color of each bar separately. You understand what I'm trying to say? That is basically a color scheme that you would want to maybe change. Yeah. But I don't know how to do that.
If you change the color, it will make all the bars one color, I think.
Yes, that's the thing, one bar. So if you want different colors for the different bars, like the one you had was nicely that way, and that makes it visually easier to see things. So that's why I say then maybe a color scheme is what you need to get to, but I don't know how myself.
Okay, so if we get to the two-way frequency table, so now we are going to have counts whether an observation is in two categories. Okay. So for this one, we use this function. So this cross tab function from the pandas library. Okay, so as the first argument, we are going to give it the first category or the first variable. And as the second argument, we're going to give it the second variable. So it's the frequency table of the categories and the species. Okay, so we are using category and species, those two variables. And we're saving it into a variable called two-way. So if we run that and we print this two-way, many categories.
Sorry, Renee?
Yes.
Yes, is lunchtime. Are you gonna stop?
I thought lunchtime is at 1.
Sorry, let me double check.
I'll also quickly double check.
Yeah, I was also not checking because I see people are begging for lunch from different institutions, but I was also told 1 o'clock. So I'm trying to find the lunch break starts at 1 until 2:30.
Yeah. I'll finish up what I'm saying now, and then just confirm if I can continue until 1, please.
Oh, because I see their schedule looks different. But now that they're sharing on the one they have, it says 12:30.
Oh yes, I think we were supposed to, Renee, apologies. I think we were supposed to share with you the updated one from the email. Yes, I think it's lunchtime now.
Okay. Okay.
Yeah,
Let me
everybody's
just
now currently posting their lunchtime schedule or the schedule, so that's fine. Yeah, sorry, we were not given the updated one. Yeah,
Yes,
Yeah.
and now
I'll
you
update
must
you.
say now.
Okay, so let me just finish this two-way table, and then we can continue after lunch. Because yeah, our schedule that we got looks completely different.
Completely,
Sorry.
yeah. It's going to be problematic, and I see to start again 1:30, but okay.
Yeah, okay, but I'll quickly finish this. So this
Yeah.
one creates a two-way frequency table. So in the rows, we have the different categories of the animals, and in the columns, we have different species. Okay, and so in this case, we have 0 animals in the coast category and the amphibian species. We have 6 animals in the coast category and in the bird species. Okay. So then I will stop now, and yeah, we can have lunch, and then we will continue at 1:30.
Sorry, yeah, we'll resume at 1:30. Hi, Paul. Hi, Renee. Hi, Paul. Can you hear me? Hi, everyone. Yes, welcome. I'm still waiting for Renee and Paul.
Hi there. Sorry. Yeah, I was busy communicating with my HOD because I have to reschedule now a few things also for tomorrow because we didn't have the updated schedule. So sorry for that.
Are you continuing, or Renee will continue?
No, Renee is not also. She also had other things scheduled. So I will be continuing on her behalf. She should be back soon. She also just had to make some other arrangements now. So
Thank
yeah, so we unfortunately have to change a bit our schedule. As I said, because we didn't have the updated schedule. I don't know when it was changed, but yeah. So what we will do now is Renee will, when she's back, continue. I don't want to mess up her excellent presentation and what she's busy with. So what we will do is we will get back to data handling, but with respect to the exercises. So let me quickly open up because I've closed it. So under Canvas, you are in Canvas. If you go to the files there, let me quickly see where that would be now. I hope she's uploaded it. Let me quickly see if I can find it. Let me quickly see on my side if I can find it. Okay, let me see if I can share my screen. Look, it seems that for some reason I'm struggling to share it. I don't know why I don't want to share. Let me try again. Is it showing my screen now?
Yes, yes.
Okay. So getting back to the data handling. So this is in the slides, data handling exploratory data analysis. So in these slides, you scroll down, there's on your own data handling. So the CSV file, that is available on Canvas, the coffee truck CSV file. So that's available for you. And you can basically make use of the data handling Python file to then answer the questions that's here. This. I don't know if it showed when I was sharing now. Let me maybe quickly stop the share because I don't know if that was showing. Let me share again and rather say just share the screen. That is better. Because if I share the screen and I jump over to show where I was showing, so in here under the CSS 2025 uploaded files, there is the coffee truck.csv file. You can basically then, as I said, use the data handling Python file and just change where necessary to answer the questions that's indicated here. Okay, so this coffee truck, it's not a quiz. It is basically a practice for you now to practice what was done this morning, not in terms yet of exploratory data analysis, just in terms of the data handling. So see if you can answer the questions asked there, but it's as a practice, it's not a quiz. I've seen that there are things for some of the other modules presented. There were quizzes, but we don't have any quizzes in our section. So this is just for you to practice. And if you have questions, you're welcome to post in the chat line on the in Slack, and I'll try my best to answer. Okay, I'm going to stop my share. So if you go to the slides as well, it will just show you the slides are, I quickly click on the right place here. The slides are also available in here. So it's not that one, it is the data handling one, it's there. So the slides are available here. I'm going to stop my share so that I can move around on my device, so that if there are questions, I can try and answer as well. Okay. So Renee says that her meeting is finished that she had. So she'll be joining us soon again. Gift, I don't see so many duplicates, but I might be doing things wrong. So Gift asked in the Slack chat channel about removing the duplicates. That then there's far fewer observations. I do not get myself so many duplicates. Just double check. But maybe I was looking in the wrong places. Let me quickly see if I just... Yeah, I definitely don't have so many duplicates. So those of you that wondered where are the questions, you can find the questions, as I said, if you go to the slides that you can download. So in the slides, where you go, the slides that is labeled Introduction to Probability under Data Handling and Exploratory Data Analysis. And it's on Canvas available. And let me quickly see what is the page number of this. Page 9 out of the 514 in the slides. Oh, thanks, Carleen. You are too kind. Carleen has kindly posted all the questions on the Slack channel. That is very nice. And I see some answers which looks correct. Well, it's the answers I also got. I have an answer of 8 somewhere for number of columns and so forth. Yeah. I see Renee is back. Renee, I'm going to mute and you can take over.
Hello. Sorry for not being able to join at the start of the session.
As I explained to them, I was also a bit late because I had to also reschedule some meetings and stuff to be on time. So
yeah. So as I understand, you guys tried the data handling exercise while I was away. Are you guys, I'm not sure how far are you, can we go through the answers?
So there are some of them that are still wondering what we are busy with. So it's under the data handling. There's a on your own exercise, and it is on a coffee truck data, which is available on Canvas. The slides are also on Canvas, so it is, the questions are on slide 9 out of 14, if I now remember correctly.
Yes, I'll put it on the screen.
Yes, I was sharing my screen, but then I had to go away because I needed to myself start coding in Python, and it doesn't help that when I do the coding, show all the answers. So thanks for sharing.
Yeah.
And there was a question from, I think it was Gift, that said he got a lot of duplicates, but I didn't get so many duplicates.
Well, I also didn't get that many duplicates.
No. No, he has more than 2,200, 2,201 to be exact. But yeah, there's something then that's not correct. There are definitely some duplicates that I found. So I have less than 20 duplicates, Renee, that I found.
Yeah, that sounds more or less correct.
Yeah.
Can't remember the exact number, but it was less than 20.
Oh, yes, there was a question, Renee, whether this is a quiz or a practice. And I think, yeah, this is just practice. We don't have quizzes. I think some of the other modules have quizzes.
Yeah. Yeah, it's just a practice. It's just for you just to try what we learned this morning just on your own. And getting your hands dirty, that's the best way to learn, to actually do it yourself. Yeah. I see people are engaging in the chat and posting answers. That looks correct to me. That's very good. I'm happy to see that. Can I give you 3 more minutes and then we go through the answers, or if you're confident enough, I can just post the answers, the coding answers, on Canvas later today. Then we can finish off the EDA, or do you guys want me to go through the script quickly? Okay, so someone did say rather post the answers on Canvas. And there was a few thumbs up, so I think I will do that for the interest of time. We have discussed all of the code in quite detail this morning, so I'm comfortable with leaving you just with the answers. All right. I think let us continue with the EDA. Let us finish that, and then we can always later on, you can continue working on the data handling exercise, and there's also an exercise for the exploratory data analysis. Okay. So let's just see. I'm just going to clear everything. I wanted to check some of the answers that you guys posted. All right. So we were busy before we took lunch. We were busy with exploratory data analysis. So just briefly again, what we were doing. So we were working with the super animals data set, and with the pick and pay cards. with the Pick and Pay cards, and we had different animals in different categories and different species with information of size and weight and conservation status and all of that. We drew a histogram of the size of the animals, and we ended off just before lunch with the frequency tables. So we had the frequency tables of just one variable. We had where we had counts and where we had proportions, and we also drew a bar plot. And then what we also did was a two-way frequency table. So where we draw a frequency table based on two different categorical variables. So that is what we were doing before lunch. Okay, is everyone comfortable with that? Can we continue?
I think you can continue, Renee.
Okay.
I don't see anybody posting in the chat anywhere, so.
I also don't see any objections to me continuing. Okay, so the next part. So I first want to show you guys just in the animals data set. We had, there's a column for vulnerability with values 1, 2, 3, and 4. So like last time, like in the data handling section, we recoded one of the variables from 0 and 1s to yes and no's. So we are going to do the same with vulnerability now. So it's a recap on that, and you had a practice, if I'm not mistaken, if I can remember correctly. But in any case, we're going to recode the vulnerability column. So everywhere where there's 1, we want to add that the animal is critically endangered. Everywhere where there's a 2, we want to say that they're vulnerable. 3, near threatened, and 4, least concern. So we have these abbreviations: CR, VU, NT, and LC. So as we did before, we are going to use a dictionary. So we first define the dictionary, where we say 1 means critically endangered, 2 means vulnerable, 3 means near threatened, and 4 means least concern. So that is the dictionary that we are defining. Okay, and remember the dictionary is in curly brackets. Okay, so we are recoding the vulnerability column. So in this case, we rewrote the column. So we overwritten the column. Before you do something like this, make sure that the code works. Okay, otherwise it starts getting dangerous. So we want to store what we are doing now in the vulnerability column. And we are taking the vulnerability column and we say we want to recode this dictionary. I think I used a different function. Okay, so this map is just a different function. You can also use the recode that we had in the previous one. In data handling, I see we used recode. Just 2 ways of doing it. And if we run this, I see recode doesn't work in this case. Okay, so we can Okay, so if we recoded it here, and we now have the new levels. Okay. Of vulnerability. So in our animals data set, we can see that vulnerability is now changed from 1s to 4s to our levels of vulnerability. Okay. So the next part, okay, there's again a little bit of repeat. Okay. So we are going to create a data set that only contains the birds. Okay, so again, we have animals dot the LOC function, the location function. We are extracting everywhere where the species is equal to bird. Okay, so we have done that in the data handling section. So it's where the species column is equal to bird. Again, we use the double equal sign. And after the comma, we specify that we want all the rows. And we save this into a variable called bird. Okay, so we have a data frame containing just the birds. So if we get a frequency table now of the vulnerability index of just the birds, so now we can use this data set that we have created with the vulnerability column, and we can dot value counts. So because that's how we get a frequency table. Okay, so if we print this frequency table, this is what we get. So we get that 27 birds had the vulnerability index of least concern, 6 of vulnerable, 2 of critically endangered, and 1 of near threatened. Okay. Note that when we do this, when we draw the frequency table, it automatically orders it from the highest frequency to the lowest frequency, which might not be the order that we want it in. Okay. So we'll get to that now. Right. So if we draw a bar plot, so we have drawn a bar plot, so I'm not going to go into too much detail. But in the x-axis, on the x-axis, we have the index of the frequency table, which is the row names. And on the y, we have the values. So we have to first draw the frequency table before we can do a bar plot. Okay. So if we run that and we go to our plots window, this is what we get. Okay, so I didn't change any labels now. This is just for illustration. But you can see that it actually, orders it according to the highest frequency to the lowest frequency. But if we want it in this order, so we want critically endangered, vulnerable, near threatened, and least concern, because there's a sort of an order of in our categorical data. Okay, like least concern is less than a concern than the animals that's near threatened. Okay, so there's order. So we are going to sort. So we take our frequency table that we have created, this one here displayed in the console, and we are going to say, let's re-index this. So we're going to reorder the indices. And in round brackets, we give it an array with the different levels in the order that we want it. Okay. So we want critically endangered first, then vulnerable, near threatened, least concern. So we specify the order in this re-index function. So if we do this, and we do this directly on the frequency table. So if we do this, and we save it now into a variable, and we print this variable, we can see that it reordered my frequency table in the order that I specified, right? And we can rerun our bar plot now on my sorted frequency table. And you can see that it does put it in the correct order. So when you have order in your categories, something that also has order is ratings, like a 5-star rating or a 4-star rating. It's important that when you make a plot or when you make a frequency table, that your categories are in the correct order so that it makes sense. Okay. Okay, so the next part that we're going to look at is the numerical summaries. So someone did ask before lunch, how do I get mean, median, and standard deviation, all that. That is what we're going to do now. Okay, so the first one that we're going to look at is it's a quick summary. Okay, so this we do with the dot describe. So we take, okay, so we're only going to consider the birds. Sorry, I had to begin there. We're going to consider the size of the birds, and we're going to get summary statistics from that variable. So we have birds, and we extract size, and that's the column, and we say dot describe. And we get a whole lot of values. So we get count, mean. So count is how many values there are. Mean is the mean of the values. You get standard deviation, minimum. You get your first quartile, median, which is your second quartile, your third quartile, and your maximum value. So this is a quick way of just seeing how your data is distributed. And what's the mean, all the summary statistics. So you can actually get it quickly with this dot describe. So let's run this, and then it's going to save what I have here into a variable called summary. Okay, so if we want to get the average, so we extract the variable, okay, and we can say dot mean. So we apply the mean function, and that will give us our mean value. But we have already got the summary, so we can also extract the mean value from the summary function, or from what we saved from this. So how we do that is the same as, almost the same as how you extract variables. So you have summary, and in square brackets, mean. Okay, so you specify the object that you want, the value that you want. Okay, just as we have it there. So we can print it. This is just another way of printing values. So we can label it. It's quite useful when you run something and you want to print multiple things. Okay. And then the minimum, again, you can get the same as with the mean. So you can extract the variable, and then you can apply the minimum function, the min function. This will give you the minimum value in the size variable. But also, again, you can extract it from summary. Okay, so summary in square brackets, min. Press the wrong button. Shift enter. Okay, so you get 13 there as well. And this one was also 13. Okay, the same for the maximum. In the case of the maximum, it's just max. And if you extract it from the summary, it's again max. Let me just show you, get the same value. There we go. And then standard deviation, remember that's a measure of variability, so how far your data or how your data is spread. Okay. And this is also from summary, so it's labeled STD, and yeah, you can get the value from there. So it depends on your situation, what you want to do, if you want to use the summary and extract values, or do you just want to get the values directly? Right, are there any questions? If someone says the plot isn't resorting, just make sure that you have run both lines. Make sure that this line 75 actually does what it needs to.
Yes, and
Otherwise,
a few people
Yes.
have indicated that it's not resorting or sorting.
Yeah, I think if it's difficult if I can't see exactly what you're running. Just run this line 75 and make sure that what is saved in this bird's vulner sorted variable is what you expect. That also
is being
sorts
used.
frequency
That's the
table.
important thing also, that must be used then in line 77, not use the
Yeah.
what was in 72.
Yeah. Someone has also posted an alternative on how you can do it in the plot function. So you can also try that. Okay. So here, if you want to draw a histogram, you can use the histplot function. We have drawn a histogram, so I'm just going to, oh no, something's not like it there. Okay, there we go. So histogram of the size. So we have drawn a histogram of all the animals. Okay, so this is the histogram of just the birds. Okay, I didn't add fancy labels or anything, but you can do that on your own time. Okay, so with numerical data, remember from the slides, you can also use a box plot as a visualization of the data. So we draw a box plot, which is basically a visual summary of the 5-number summary. Okay, and you can see the box plot for the size of the birds. Okay, in this case, we have 2 dots here at the end, which means there's 2 outliers. So there's 2 birds with outlier sizes. So with the box plot, again, you can also add labels and change the colors and play around a bit with the settings. It's always nice when you want to do something, when you try to Google and see how you can change it up a bit. So the next is again some summary statistics that we are going to get. So it's the median and the interquartile range. So these are 2 measures that you can use for numerical data that's a measure of location and a measure of variability that's robust to outliers. Okay, so outliers doesn't affect the value of the median or the interquartile range, which is not the case in mean and standard deviation. So with the median of the size of the birds, again, you extract the size variable and you apply the median function to that. Okay. Yeah, so we have that as our median. And our median is our 50th percentile. Okay, so that's the exact middle of the data, which is also our second quartile. So we can extract that from the summary as the one that says 50. Just quickly print summary again. So the one that says 50%, that is our median value. Okay, so we can also extract it from there. And then the interquartile range of the size of the birds. So interquartile range is your 3rd quartile minus your 1st quartile. So it's the 75th percentile minus your 25th percentile. Okay. So it's not explicitly stated in summary. So we have to use the values in here to actually calculate it. So how do we calculate it? It's just by the value that we extract from the 3rd quartile minus the value that we extract as the 1st quartile. So that will give us the interquartile range. Right. Any questions before I continue? Okay, there's one that asks, there's no function for interquartile. Is there no function? I haven't seen one that's in one of the basic packages. There might be, but it's such an easy calculation. So it's not necessary if you if it's such an easy calculation, then yeah. But if you can find a function, you can use it. It will give you the same answer.
Yes, I
So,
quickly
right.
checked, Renee. I checked and
Yes.
quickly Googled, and I cannot find a quick function. So there might well be a function for interquartile range available, but not one that
Yes.
is immediately coming up.
Yeah, I also can't recall a function that's easily accessible. Okay. So we're almost at the end of this, of the script. So if we draw a scatter plot of the size of the birds versus the weight of the birds, we use the scatter plot function from Seaborn. Okay. And this is so we start by specifying which data we're going to use, and then the X variable and the Y variable. So the X is the variable that will be plotted on the X axis, and the Y will be the variable that will be plotted on the Y axis. Okay. Again, you can add labels and titles and everything. I just didn't do it. Okay. But here's the size on the X-axis and the weight on the Y-axis. And you see, it makes little dots for each observation. Okay. And we do note an extreme outlier here at the right-hand side. Okay. Can you guess which bird that should be? I hope I'm guessing correctly. Okay, so I see there's an answer saying ostrich. So yes, I also believe that that should be an ostrich. Pulling the data, it's very skewed. Okay. So I see there's a question asking, how can we show the trend line on the scatter plot? So I haven't included it here, but I'm sure if you Google, like it can give you a smoothed line. But tomorrow I think we'll do some regression, and we'll add regression lines. I hope that's what Paul is planning.
No.
Okay, but you can
regression,
do it. Sorry?
Yeah, it should be able to be done, yes. To add this, the trend line or the regression line, yes. Should be able to do that.
I know you can add a regression line. Yeah. Right, so a way of dealing with with such data that has such extreme outliers, just to be able to visualize it also more properly, is you can do a transformation of the data. So in this case, you can do a log transformation on the size of the birds. So then you visualize the log of the size and the log of the weight. And then, yeah, instead of the just these sizes. So how you do that is we're going to create two new variables, the one bird's log size and bird's log weight. So then we use the log function from the NumPy package. Okay, so this function is the natural logarithm. If I hover over the function, it actually gives me some information about the function. It's the natural logarithm. So it's log base E, which is the most common one to use. Okay. And as the argument, you can give it the variable that you want it to transform. So we are transforming the size and the weight of the variables. So I have log size and log weight. Okay. And we can draw a scatter plot the same as what we did just now. But in this case, we can just use the variables that we just created, bird's log size and bird's log weight as the X and the Y. And you can actually see that the trend in the data can be better visualized with the transformed data instead of using the raw data. So there's someone saying, is there an advantage using NumPy to log the variables instead of using, okay, so instead of doing it with the directly in the plot function, so if you just want to make a plot like we did, it's either or, whatever is easier for you and for your situation. If you want to use the variable further in an analysis or maybe calculations on it, then it's better to store the values like we did. So it depends on your application and what you want to do. Right. Then the last part of the exploratory data analysis is we are going to explore numerical data across different categories. So up to now, we have done frequency tables, we have visualized categorical data, we have drawn numerical summaries, we have obtained numerical visualizations such as the box plot, scatter plot, and the histogram. So now we are going to do it across categories. So we're going to create a summary of the size variable for each species. Okay, so we remember, if I go back to the data set, we have a variable called species, where we define bird, mammal, there's an insect. Okay. So we are going to get numerical summaries per species. So instead of subsetting the data and getting it manually for each category, we're going to do it all together. So how we do that is we are going to use group by. So we have animals.group by. So we take our data set and we're going to group by. In our round brackets, we are going to specify by which variable do we want to group. We want to group by the species variable. So that is what's done in this code that I'm highlighting now. So we are grouping by the species. Okay. So now imagine in your head that your data set is now split into different groups according to one of the categorical variables. From this grouped data, we want to use the variable, the numerical variable size. So after this, after everything, after the round bracket is closed, we are going to use, we're going to extract the size variable. The size variable. Yeah. So this part that I'm highlighting now is the size, is your data set grouped into the different species, but you're only considering size variable now. And then you are going to describe, so you're going to apply this describe function to our groups that we have created now. Okay, and we are going to, let me just drag this console a little bit bigger. You can properly see. So now from this, we have for each species, we have that summary. So we have count, mean, standard deviation, minimum for each species, for each type of species across the categories. So instead of having to subset your data, the whole subset for each species and then getting the summary statistics, you can do it all in one step. Okay. So in this case, we obtained all the summary statistics in one go, but you can also use this syntax to get separate summary statistics such as mean, median, standard deviation. That's just an example. So you can use all these summary statistics that I had here at the top, the median, standard deviation, all of that, you can do it by group. Okay, so you can get the mean. So this will give you the mean of each one, for each category. You can get the median. You can get the standard deviation, etc. Quickly in one go. Someone just asked again, what does describe do? So describe is the function to get all of these summary statistic values. So the describe function describes your data. So it gets the count, the mean, standard deviation, minimum, your quartiles, and your maximum in one go without having to do it individually. Someone's asking, can we transpose the columns and the species? I'm sure you can. Try and, yeah, I haven't done it. I haven't had the need to do it. But if you want to, it's just the way it's displayed here. So try to see if you can get it right, and then please share with us.
There's a reshape that can be used, Renee.
Oh yes, I recall something about the reshape.
Oh yeah, we're going to need it tomorrow with the regression, where in the background it's matrix multiplication getting used, and we have to reshape. I remember X, you say a row vector and it's become a column vector. So yeah, so that transpose a row to become a column or a column to be a row. But I can't remember now the details.
Yeah. Yes, please try it out, and if you get it right, please share with us, so that we can all learn. Okay. So the last part of the script is subsetting, or we're going to draw a side-by-side box plot. Okay. So in this case, it's just because we want to repeat something or show you, just re-emphasize how you subset. So we're only going to consider the birds and the mammals. Okay, just those two together. So we're going to subset the data again according to species. So we have animals dot loc dot the location. Okay, and animals species, that's the variable on which we want to subset. And we want to know whether they are a bird or a mammal. Okay. The previous example, we had this array that we have here separately. But in this case, it's everything in one line. It is neater if you have it separately, but yeah, just showing that you can do it in one line. Okay, so we say the species has to be either a bird or a mammal to be included in this data set. And we are subsetting all the columns. So we call this birds underscore mammals. And then we draw a side-by-side box plot. So a side-by-side box plot is very handy when you want to compare numerical data across categories, when you want to quickly compare it, to compare spread, location, etc. So we use the box plot function as we had before. Remember, we had the box plot function. We specify the data, okay? And then we specify the variables. So in this case, we have to specify two variables, an X and a Y. So we specify our X variable as size, because we want a side-by-side box plot of the size of the birds and the mammals. And on Y, we specify the species. So this code, before I run it, is going to draw a side-by-side box plot with a box plot for the size variable for each category in species. For the size variable for each category in species. In this case, there's two categories, bird and mammal, because we subsetted. So if I run this, go to plots, I get this plot of the two box plots. So one for the mammals and one for the birds. So you can actually see that the spread of the mammal species, of the size of the mammals, are much bigger than the spread for the birds. Which makes sense if you think on how big a mammal is and how big a bird is. Okay. And the mammals have many more outliers than birds. Then, yeah, the birds only have those two, mammals have this 5. Right, are there any questions? Okay, you're asking why mine plotting different colors without specifying. It might be that I have a different version of the package than you, if yours are not plotting that way. But I do believe it's a default. But you will be able to set the colors. That will be a nice exercise to see if you can set the colors yourself. Okay. I believe it's tea now. There's a tea break, if I'm not mistaken.
Yes, that's the team break
Until,
now.
yeah, until 1/4. So, yeah, let's break for tea, and then we see everyone back in 15 minutes. Hello. I see someone is asking if everyone is back. I'm definitely back.
Yes, and I.
Are you okay?
We can
Paul's also
continue.
back.
Yes.
I see there's a question in the chat, and I do think maybe, Paul, you will maybe have a better explanation than I would. It's about the log transformations.
Yeah, so within statistics, we often have to do a data transformation, and it depends on the data values that you have. So the log transformation is the most popular transformation used, and it is when you have a data set that is skewed, and skewness often is present when you have outliers in your data. So the box plots, for example, that Renee showed, where there were outliers to the maximum side of the data, so large outliers, but it could also be to the other side. When you have skewed data, then it is problematic for some of the inference that we want to do for hypothesis testing. So it's then better to apply transformation to get your data symmetric, and for that the log transformation can be used. But there are also other transformations available. You can take a square root transformation, you can take a reciprocal transformation. It depends on your type of data that you have. For example, the log transformation does require that your observation values must all be positive. You cannot have zeros or negatives. And I do see that in the chat line, somebody has NINs everywhere, and that shows that there's something wrong with the data. I assume that was after the log transformation was applied, that it was applied. It couldn't be applied on the variable. I guess that's where the NIN come from, but I'm not sure.
I see it's the vulnerability column, but
Oh yes, because you cannot apply log transformation to the vulnerability because that's characters.
yeah.
But I don't know if the
but
transformation was applied there. That could be that it's not. But that's not where that comes from.
yeah, I will have to see what happened with the code. Can't. There's many things. Oh, they say they managed to fix it.
Okay, wonderful.
Okay. Thank you. So then for this last part, let me just share it again. Okay, so we did the data handling exercise just after lunch. And so with the EDA, there's also an exercise on the same data, also the coffee truck data. So yeah, I think in this last session we can do this exercise. So it's important, don't use the data from the data handling section where you remove the duplicates and sorted and subsetted. Start fresh now. So import the data again and do this exercise. Okay, so separately from the data handling exercise. Yeah, so if you want to know anything, then you can just ask, and we can assist, or you're also welcome to answer other people's questions. And yeah, I can post the answers of this as well on Canvas. And if there's any question you want me to go through with you again, or with you guys, free field to ask, and we can do that. So I see someone's asking, can you show us how to do subplots together? So I haven't done subplots in Python before. If what's in my mind, what you want, but I'll see if I can, while you're busy with the exercise, see what I can do.
Yes, sorry, it's also not something that I've tried to do.
I see there's many people that has put answers and plots and everything in the chat. So it looks great. Well done. And there was someone that asked about the subplots. So I replied to that message with a screenshot of some code that you can do subplots. Yes, but just again, remember like these sessions are what we're presenting is just to get you a little bit excited. Just to give you a brief introduction of what you can do. So there's obviously many more things that you can do, and you can always just Google is your friend with coding. Go try different things. Google, see what you can come up with. Once you start exploring, it becomes quite exciting. I see more answers coming through, and people sharing their code. That's fantastic. So I will post the 2 exercise question, or the exercises. I will post those answers on Canvas. Yeah, so I will post those answers on Canvas, so you can go and look there. I will post it shortly. So yes, I think that is all from my side today. There's still 15 minutes left, so we'll hang around. Not sure if, Paul, if you have anything to say or to excite them about tomorrow.
No, not at this stage, no. But what I am doing tomorrow should hopefully link to some of the things that were done today.
Yes, so someone says please include the code. So I'm going to add the coding scripts. So that you can see the code that I wrote to get the answers. Okay, I think if there's no, if you don't have any more questions or something, I'm happy to close the day. I just want to say thank you for your participation today. It was lovely seeing everyone engaging and doing the exercises and applying what we've went through. And yes, then we see you tomorrow. And Paul I will be online, and Paul will take you through some more statistical analysis things. And yes, look out for the answers. I will post them shortly on Canvas. Thank you.
Thanks, Renee.
Thank you, Renee and Paul. Thanks, everyone.